Previously, we have discussed halocarbon compounds, which is the classification of the primary compounds we are going to see. And I am going to just a brief review of the halocarbon compounds. In that halocarbon compounds, these compounds are obtained by replacing one or more hydrogen atoms with ethane or methane with halogen. So halocarbon compounds are commercially known as the freon, genetron, isotron, and the aristron. So these refrigerants have a wide range of boiling point at 1 atmospheric pressure. So these satisfies the requirement of the domestic, commercial, and the industrial application over there. So general properties of these refrigerants, we have seen that these are the non-toxic, non-flammable, non-explosive, non-corrosive, colorless, and the odorless. So next we are going to see that the halocarbon compounds, these are the suitable for the all types of the compressor, reciprocating compressor, centrifugal compressor, and the rotary compressor. And the applications, as we have discussed, air conditioning plant, refrigerator, frozen food, ice cream cabinets, then water cooler, window air conditioner, and the automobile air conditioner, low temperature application. So these related with the halocarbon compounds. Next, secondly, we are going to discuss related with the azeotrophs. Azeotrophs means what? Azeotrophs refrigerants. So mixture of two or more refrigerants with similar boiling points when the change phase takes place at specific single temperature. So suppose we are taking the example of the azeotropic mixture, that is the series in the 500. Suppose we are taking R500. So in that R500, 73.8% is the R12 and 26.2% is the R152. So the chemical formula, this R500 becomes CH3CF, CH3CH, CF2. So in this we are observing that in the azeotrope we are mixing the R12 refrigerant and the R52 refrigerant. Similarly related with the azeotropic R502. So in this azeotropic R502, 48.8% is the R22 and 51.2% is the R115, and the chemical formula becomes CHClF2. So in this azeotropic properties, we are finding zeotropic refrigerants. These are the mixture of two or more refrigerant with dissimilar boiling points when it changes its phase over there. So these azeotropic refrigerants and the zeotropic refrigerants and non-azeotropic refrigerants. Suppose we are saying that the azeotropic refrigerants are mixtures of the two or more refrigerants with similar boiling points, and related with the zeotropic refrigerants, mixture of two or more refrigerants with dissimilar boiling points when the phase change takes place over the temperature over the 5.56 degrees Celsius. Examples are the R404A or R407C. So these are the zeotropic refrigerants. So in these refrigerants also, non-azeotropic refrigerants means what? Mixtures of two or more refrigerants with dissimilar boiling point, but phase changes takes place over the temperature ranges less than the 5.56 degrees Celsius. So application of these azeotropic refrigerants, we are generally use these azeotropic refrigerants in medium or low temperature applications, then frozen food processing plant, frozen food display cases, frozen food lockers, or storage unit of ice cream. So in these cases we are using this refrigerants. So we are generally mostly we are using the reciprocating compressors in the azeotropic refrigerants. Next is the hydrocarbon compounds. Means what? Hydrocarbon compounds are produced from the petroleum in an oil refinery, and these refrigerants have desirable thermodynamic properties, and these are highly inflammable. So some important, suppose we are seeing the example of the some of the important hydrocarbon refrigerant, that is R50, we are calling it as a methane, CH4. Next R170, we are calling it as a ethane, and the chemical formula C2H6. So these are some of the example. R290, that is propane, that is C3H8. Next R600 butane, that is C4H10. So hydrocarbon compounds are used in the refrigeration system in oil refineries and the petrochemical industry due to their low cost and ready availability. So several organic compounds of these groups are used as a refrigerants for commercial and industrial application over there. So these related with the hydrocarbon compounds. Next we are going to see inorganic compounds. Inorganic compound means, or inorganic compounds are further classified as a cryogenic or non-cryogenics. So cryogenic fluids, those are which applied achieving the temperature minus 160 degrees Celsius to minus 273 degrees Celsius, and above these ranges which we can use multi-stage refrigeration system with desired temperature. But below minus 160 degrees Celsius this is not possible, since COP of the cycle becomes too low. So to attain the temperature below minus 160, we use the refrigerant as a nitrogen, oxygen, helium for the closed temperature minus 273 degrees Celsius. So inorganic compounds which are employed above cryogenic temperature ranges come under the remaining subdivision of the inorganic refrigerants. So example is the ammonia, water, air, carbon dioxide, sulfur dioxide, and we are generally giving ammonia as a R717, and water R718, air R729, carbon dioxide R744, sulfur dioxide R764, and these are generally general properties of the inorganic compounds are these are non-flammable. Then such as the ammonia, non-irritating, CO2 properties they have given, non-flammable, non-toxic, non-irritating, and ammonia generally we are using in the cold storage, beer manufacturing, ice cream manufacturing, warehouse plants, and the food freezing plants. And these carbon dioxide we are using the household units, industrial application, ship air conditioning. So we have seen the application of the inorganic compounds over here. Now generally we are using the reciprocating compressor for the inorganic compounds. So this is the classification related to the refrigerants. See, refrigerants classified into basically two main major, that is the primary and secondary. In primary we are saying that the primary refrigerants are those refrigerants that pass through the process of compression, cooling, condensation, and expansion and evaporation, or warming up during the cyclic process. And the secondary refrigerants, the medium which does not go through the cyclic process in a refrigeration system and is only used as the medium for the heat transfer, and these are referred as the secondary refrigerants. And the primary refrigerants, these are again further classified as the halocarbon compounds, azeotrophs, then hydrocarbon compounds, and the inorganic compounds. So this is the classification of the refrigerants. So in the next part we are going to see how the formulas of these refrigerants we are going to be derived. So this all about the today's lecture. Thank you very much.